Hello viewers, welcome to my channel. My name is Mr.Adebanjo. In this video we are going to be discussing together Neco 2024 for the mathematics the theory part of the question. In our previous video we have solved the Neco 2024 for the mathematics objective questions, and if you have not seen that video you may need to go back and refer to the video if you truly need to understand the Neco 2024 for the mathematics both objective and the theory. And what are we going to be doing in this video? Of course we are going to be telling you the topic where each of the questions managed from. We're going to be solving each question step by step together in this video, and we have all 15 questions to solve all together as far as this video is concerned. Before we get it started, if you are yet to subscribe to this channel, please do subscribe right now by clicking the subscribe button on the screen right now, on the channel right now. Pardon me for that. If you have not done that before, so help us to subscribe to this channel so as to help us improve on this channel, and share this video, like it, and comment in the comment section of this video to help us improve on the next video. And as you do so, may the good Lord bless you. So let's jump and see what we are to discuss as far as this video is concerned. Now the first question is what you are seeing on the screen right now, and the question number A is from Indices. You have to solve the equation 5 raised to power 1 minus 2y is equals to 0.2. so like I said, it's from Indices. So of course this is an initial equation. We have 5 raised to power 1 minus 2y equals 0.2. What you need to do is to change this 0.2 to a fraction, and that should give us and this 1 over 5 can be changed to an index form, and that should give us a 5 raised to power minus 1. So we have a 5 raised to power 1 minus 2 equals to 5 raised to power minus 1. Then the base can take care of the base. So you have a 1 minus 2 is equals to minus 1. Then from there you can collect like terms. So we have minus 2 equals to minus 1 minus 1, and that should give us a minus 2 equals to minus 2. S will be equals to 1. So that's solved the question number 1A for us. Then question number 1B is from the logarithm. You have to simplify log 9 base 3 plus log 28 base 3 plus log 0.75 base 3 minus log 7 base 3. So of course this, like I said earlier, is from the logarithm, and in this case we have to solve this logarithmic expression using the logarithm laws of logarithm. And if you understand this statement very well, you understand that this can be solved step by step. You can apply law of logarithm since they all have the same base. Law of logarithm to solve this, like I said. So that will give us a log 9 times 28 times 0.75, then divided by 7. Addition to they will change to times, and the minus change to division. Then from there apply how this number, then divided by 7. If you multiply, if you do that, that gives us a 27. So you have log 27 base 3. And what does this really mean? Log 27 base 3 means how often can you raise 27 to get 3? How often can you raise 27 to get 3? So that should be 3. So log 27 base 3 should give us 3. Having done that, if you know that, you can simplify this further by changing this one to an index form. That gives us log 3 base raised to power 3. Then this power come to the back here. You have 3 log 3 base 3. So log 3 base 3 give us 1. So that means give us 3 times 1 equals to 3. So that's solution for question number 1B also. Question number 2 is from the quadratic equation. In this case, sum and product of roots of quadratic equation. Sum and product of roots of quadratic equation is where the question comes from. We are told that if alpha and beta are roots of quadratic of 2x squared minus 3x equals to minus 1, we have to find the value of alpha squared plus beta squared, alpha cube plus beta cube, 1 alpha over beta plus beta over alpha. So of course we are given the quadratic equation 2x squared minus 3x equals to minus 1. The first thing to do is to return this minus 1 here. So that gives us 2x squared minus 3x plus 1 equals to 0. So from there we know the value of our a to be 2, which is coefficient of x squared. Our b will be minus 3 and our c will be 1. So now that means you can find the sum and the product of the root of this quadratic equation. if alpha and beta are the roots, so that means alpha plus beta, that will give us the sum of the roots. Alpha plus beta will give us the sum of the root, which is equals to minus b over a, and equals to our b is minus 3 over a, which is 2. So minus times minus give us plus, so that gives us a 3 over 2 for the sum of the product of the roots of this quadratic equation. Then the product of the root of this quadratic equation, that is alpha beta, and that will be equals to c over a, and our c is 1 and our a is 2. So product of the root of that quadratic equation is 1 over 2. Now that we know the sum and the product, we can now simplify alpha squared plus beta squared. Alpha squared plus beta squared, if you expand this, that should give us alpha plus beta squared minus 2 alpha beta. Alpha squared plus beta squared will give us alpha plus beta squared minus 2 alpha beta. Then we know the value of alpha plus beta, which is 3 over 2, and we know the value of alpha beta, that is 1 over 2. If you put that here, so that should give us 3 over 2 squared minus 2 multiplied by product, which is 1 over 2. So 2 will take care of 2 here, so that should give us 3 over 2 squared will give us 9 over 4. Then 2 will take care of 2, that gives us minus 1 here. And if you simplify this by finding the LCM, that will give us 5 over 4, which is simply 1 number 1 over 4. So that is for alpha squared plus beta squared. Then for alpha cube plus beta cube, so we need to expand this as well in terms of alpha plus beta and alpha beta. And if you expand that as well, that gives us alpha plus beta cube minus 3 alpha beta into alpha plus beta. So we know the value of alpha plus beta, we know the value of alpha beta, we know the value of alpha plus beta as well. If you substitute into this, we have 3 over 2 cube minus 3 times alpha beta is 1 over 2 times alpha plus beta is 3 over 2. Then from there, if you expand these brackets, that will be 3 cube over 2 cube. That should give us 27 over 8. Also, 3 times 1 times 3 give us 9. Then 2 times 2 give us 4. If you find the LCM here and simplify, LCM is 8. That will give us 27 minus 18. And that should give us 9 over 8, which is 1 over 1 over 8. Then for the last one, which is the alpha over beta plus beta over alpha, if you simplify that also, we can find the LCM of this, and that should give us alpha beta. The LCM is alpha beta. Beta in alpha beta give us alpha. Alpha times alpha give us alpha square, plus alpha in alpha beta will give us a beta. Beta times beta give us beta square. So we know the value of this, the numerator, which is the answer we got here, which is 5 over 4. If you substitute that here, we have 5 over 4 divided by alpha beta is 1 over 2, which could be written as 5 over 4 divided by 1 over 2 like this. And you can change this division to times, that gives 5 over 4 times 2 over 1. And then from there, 2 can go in 4 here, that gives 5 over 2. And if you simplify further, that should give us a 2 number 1 over 2. So that's the solution for question number 2 also. Question number 3 is from the sequence and series, in this case a geometric progression. We are told that the sum of the first 3 terms of a geometric progression is 19 and their product is 216. Find the first 3 terms. So we know that the first term of a geometric progression is a, and the second term of the geometric progression is ar, and while the third term of a geometric progression is ar square. We are told that the sum of these 3 terms will give us 19. So if you add all these 3 terms together, that should give us a plus ar square equals to 19. Then they have something in common that we can factorize, which is a is common here. We can factorize a. So that means we have a into 1 plus r square equals to 19. So we have factorized 8 out of this, so that gives us a into 1, because a in a will give us 1, a in r will give us r, a in ar square will give us r square equals to 19. And also we are told that the product of these 3 terms will give us 116. So that means if you multiply them together, if you multiply them out, a times ar times ar square, that gives us 116. And if you multiply them out, that should give us a cube, then r cube equals to this. So we have a cube r cube equals to 216. Then from there, which can be written as a ar raised to power 3 equals to 216. Then from there we can find the cube root of both sides. We can take the cube root of both sides. That will give us ar equals to 6. Then from there we can make a sort of the formula here. A will be equal to 6 over r. That can call that one equation 2. Then we can now put equation 2 into equation 1. So that is wherever we see a, we put 6 over r there. So that will give us a 6 over r multiplied by this equals to 19. So put equation 2 into equation 1. We have we'll be having 6 over r into 1 plus r squared equals to 19. Then from there, what can we do? We can open the bracket by multiplying through by r. If you multiply this one by r will take care of r. So multiply this one by r, then we have 19r. Then 6 will open the bracket. You have 6 plus 6r plus 6r squared equals to 9r. Then from there, what can we do? We can take this one to this side so that it can now give us a quadratic equation to solve. So we'll be having 6r squared minus 19r plus 6r will give us a minus 13r plus 6 equals to 0. So we have a quadratic equation to solve now using any method that you know, but you can solve this using factorization method. So 6 will multiply 6, that will give us 36. Then we can now look for two numbers you can multiply together to give us 36, and when you add them together give us minus 13. And then that should be minus 9 and minus 4. Minus 9 times minus 4 give us 36. Then minus 9 minus 4 give us minus 13. So if you now write this like this, so we have 6r squared minus 9r minus 4r plus 6 equals to 0. You can factorize 3r here. So 3r into 2r minus 3 minus 2 is common here. You have minus 2 into 2r minus 3 equals to 0. Then bring this and this together. So you have 3r minus 2 into 2r minus 3 equals to 0. From there, if you find our r, you'll be having r to be 2 over 3, or r will be equals to 3 over 2. So that's the common ratio. Then you can now find our a when we know our r. When our r is 2 over 3, then we can find our a from here. Our a is 6 over r. Then you have 6 multiplied by our r is 3 over 2. So our r is 2 over 3 rather. So you're having 6 over, that division can be changed to times. That means you need to inverse this. That gives us 3 over 2. Then 6 times 3 give us 18. Divided by 2, that gives us 9. So that means the first time is 9 when our r is 2 over 3. Also when our r is 3 over 2, so we can also find our a. So a will be equals to 6 over r, which is also equal to 6. Then division will turn to times. So times, then inverse the fraction, that will be have 2 over 3. 6 in 3 will give us 2. 2 times 2 will give us 4. So when our a is 4, our r is 3 over 2 as well. So knowing this now, that when our a is 9, which is this, our r is 2 over 3. Then question asks us to find the first 3 terms. So we need to find the first term will be 9. So the first term of the sequence is 9. Then we can now find the second term now, which is t1, which is first term is 9. Then also you can find the t2 now, which is ar. So our a is 9, then multiplied by the r, which is 2 over 3. So 3 can go in and that give us 3 times 2, that give us 6. So the second term is 6. You can also find the third term, which is ar squared. That give us 9 times 2 over 3 squared. That gives us 9 times 4 over 9. That gives us 4. So that means the terms we are looking for, the first term is 9, the second term is 6, and the third term is 4. So that is only possible when our a is 9, our r is 2 over 3. Also, we also know that when our a is 4 here, our r was 3 over 2. So you can also find another term for that as well. So when our a is 4, our r is 3 over 2. So that means the first term here could be 4 also. Then you can now find the second term will now be ar. That means you have 4 times 3 over 2, that gives us 6. Then the third term also will give us ar squared, that gives us 4 times 3 over 2 squared. That gives us 4 times 9 over 4, that gives us 9. So that means the terms could also be 4, 6, 9. It could be 9, 6, 4, or it could also be 4, 6, 9. So the first 3 terms could be like this or like this. So whether in descending order or in ascending order. So that's solution for question number 3. Question number 4 is from the equation of circle. We are told that if the equation of the circle whose center is the same as that of the circle, s squared plus y squared minus 6s plus 4y minus 3 is equal to 0 and passes through point 5, 4. So we have to find the equation of the circle that passes through the center of this circle and passes through this point. So the first thing to do is to first of all find the center of this circle. This circle here, you need to first of all find the center of that circle so that we know the center of the circle of the equation we are looking for. So what do? Before we find the center of this circle here, before we find the center of this circle, then after knowing that, you can now find the equation of the circle you are looking for, because we are told that they both have the same center. That is, they have the same center. The equation we are looking for has the center of this as well. So how can we find the center of this circle? So if I use by using completely the square method. And how do we do that? So collect like time, or forward take this constant to this side. So we have a s squared minus 6 plus y squared plus 4y equals to 3. Then you can complete this square. You can also complete this square as well. So for this x, let's also complete the square for x. So if you have and square the equation of x and add it to both sides. You also have and square the equation of y and add it to both sides as well. So the equation of s here is minus 6. If you have it, that give us minus 3. If you square it, that give us 9. Equation of y here is 4. If you have it, that give us 2. And if you square it, that give us 4. And if you add it to both sides, that means the equation becomes s squared minus 6x plus 9 plus y squared plus 4y plus 4 equals to 3 plus 9 plus 4. So from there now, if you simplify further, we need to make this a perfect square. Make this perfect square, that will give us x minus 3 squared plus make this also a perfect square as well, that will give us y plus 2 squared equals to, add this together, that will give us 16. Then from there, if you compare the equation of the circle, given that the center of the circle is a comma b and the radius is r, so which is this equation you're having here. So if you compare this and this, then that means the center will be you compare a and 3 here, you compare b and 2 here. So that means the center of the circle will be 3 comma minus 2. So that means the center of this circle is 3 comma minus 2. Then you can now find the equation of the circle you are looking for. Now, of course, we need to first of all find the radius of the circle we are looking for. And how can we do that? We know the center of the circle now to be 3 comma minus 2, because we are told that this circle and the circle we are looking for have the same center. So if this is the center of this circle, so that means the center of this circle as well is going to be 3 comma minus 2. And we are told that this circle passes through 5 comma 4. So that means there is going to be 5 comma 4 here. The coordinate of this point here is 5 comma 4. So but we need the radius of this circle to be able to find the equation of that circle. And the radius of the circle is from here to here, which is the distance between this center and this point. So we can use the equation, the formula of finding the distance between 2 points to find the radius of the circle. So that will give us a radius to be equal to square root of the change in s squared plus change in y squared. So where our s2 is 5, our s1 is 3, and our y2 is 4, our y1 is minus 2. If you substitute that here, so we have our r to be equals to square root of 5 minus 3 squared plus 4 minus 2 squared. We simplify that further, that will give us a 2 squared, that will give us a 6 squared. So we have 2 squared plus 6 squared, that will give us a square root of 4 plus 36. So that will give us a sort of 40. So that means the radius of this circle is a sort 40. Now if you now put that into this formula, which is the formula for finding the equation of a circle given the coordinate of the center and the radius of the circle. So we have that s minus a squared plus y minus b squared equals to r squared. Then from there, what can we do? That means our a will be 3 and our b will be minus 2. So if you substitute that back, we have x minus 3 squared plus y minus 2 y plus 2 squared, because our b is minus, so minus and minus give us a plus. Then sort 40 squared. Then from there, if you expand this, we'll be having s squared minus 6s plus 9 plus y squared plus 4y plus 4, which is what you're having from here. The expansion is similar to what you're having here, but what they have in different is the radius. So if you do that, if you collect like terms now, we have s squared plus y squared minus 6s plus 4y plus 13 then minus 40 equals to 0. Because 9 plus 4 give us 13, then bring this 40 here, you have minus 40 equals 0. Then if you simplify further, that should give us a s squared plus y squared minus 6s plus 4y minus 27 equals to 0, which is the equation of the circle we're looking for that has the same center with this circle and passes through this 5,4. Question number 4b. What is the length of the tangent to the circle, this circle, from point 5,6? So you have to find the length of the tangent to this circle. And don't forget that this is the circle we just this is the circle that we just got in the previous question number 4a. So how can we find the length of the circle to the length of the tangent to this circle? So of course, if you draw the circle, so there's a line, a tangent to this circle, which is a straight line that is touching the circumference of the circle at a point. Then let's call this point where the tangent is touching the circle T, and this point let's call it P. We are giving the this point where the tangent extends to, which is a 5,6. So we need the radius of the circle, and which is and we need the center of the circle as well. So, and how do we do that? If you remember that this circle here is the same circle that we did in the previous slide, let's go back there so that you can see it's still the same circle we are having here. So that means we know the center of the circle, which is 3, minus 2, and the radius is sod 40. So remember that the center is this, and the radius is sod 40. So let's go back and go back to what we were talking about. So we need the center of the circle, which is going to be 3, minus 2, because it's still the same equation. Then the radius is sod 40. So our aim is to find the length of this tangent. The length of this tangent. So how can we do that? We can find the distance between this point and this point, point O and point P, which is the line joining them together. We can find the distance between this now, because this is this radius is perpendicular to the tangent, so that means there will be right angle here. Are we there now? So now we know from the radius, which is sod 40, we can find the distance between O and P, which is give us the length of this line OP. So we can now use Pythagoras theorem to find the line TP, which is the length of the tangent we are looking for. Do we understand that? Good. So let's find distance OP using distance between 2 points, giving their coordinates. So that should give us a square root of change in s squared plus change in y squared. So, and if you substitute our answers, our s2 is 5, our s1 is 3, our y2 is 6, our y1 is minus 2. If you substitute that, we have a sod 5 minus 3 squared plus sod plus 6 minus 2 squared as well. If you simplify that, give us a 2 square plus 8 square, and that should give us a sod 68 if you simplify further. Now we know that this side, the OP side, OP will give us sod 68. So we can now use Pythagoras theorem to find the length of the tangent TP. So using Pythagoras theorem, OP, which is OP square, which is the hypotenuse square, equals to OT squared plus TP squared. So our OP is sod 68. So you have a sod 68 squared equals to our OT sod 40 squared plus TP squared, which is the tangent we are looking for, length of the tangent. Sod 68 squared, that gives us 68, and sod 40 squared, that gives us 40 plus TP squared. Collect like time, TP squared will be 68 minus 40, that gives us 28. Then take square root of both sides, that gives us 28 units, or we can call it, change it to decimal number, that will be 5.29 unit approximately. So that ends question number 4b. Question number 5 is from the equilibrium, that is mechanics. So from equilibrium, you are told that that's equilibrium. Okay, yes, that's a moment. It's from a moment. So you are told that a uniform plank AB of a length 100 centimeter and the weight 45 Newton rests on the support 35 centimeter from one end A. At A weight of 35 Newton is subtended. Determine the weight that will be attached to B to keep the plank in equilibrium. So the question is from moment about an equilibrium. So now if you try to scale the diagram for the question, if you try to represent it on a diagram, we have a uniform plan, which is this, and we are told that it is labeled AB. The end of the plank is labeled AB, and the length of the plank is 100 centimeter, as you have been told. So that means a uniform plank. So, and we are told that this plank weight is 45 Newton. So that means the weight of this plank is 45 Newton, and we know that the weight is going to be at the center, which is because from the length of this is 100. So that means the weight is going to be acting at the center, which is going to be 50 centimeter here. So at the center of the length of the plank. So that means the weight will be acting at this point. Let's go on. I told that this plank will rest on a support at 35 centimeters. So that means there's a support. Let's say there is a support that this plank is resting on, and the point where this the support is 35 centimeters. So we have 35 here, and from one end A, okay, this support is from 35 centimeters from one end A. So the distance of this support from point A is 35 centimeters. You have been told here. So at A weight of 35 Newton is suspended. So that means there's a weight suspended here. So and that weight is 35 Newton. As you can see, then we have to determine the weight that will be attached to B. So that means there's another weight that will be attached to this B here to keep it in equilibrium, which is the rest position. So if you attach that weight here, so we have let's name the weight W. So we are naming the weight that is attached to this point B, W, which is what you are having here. So how can we find the weight here? So we need to use the principle of moment. So we need to use the principle of moment, that is the clockwise moment must be equal to anti-clockwise moment. So the clockwise moment must be equal to anti-clockwise moment. So the moment here should be equal to moment here as well. So what can we do about that? We can see that the moment is calculated by the weight multiplied by the distance. So the distance between this weight and this point of support here is that will be weight multiplied by the distance. This is 100 minus 35, so that gives us 65. So that will give us W times 65. That is for clockwise moment. Then anti-clockwise moment, that will be the moment between this object, this weight, and this point. Then the weight of the plank, and the distance from here to here as well. So technically the anti-clockwise moment will be the moment here plus the moment here as well. The moment of this weight plus the moment of the weight of the plank to be equal to the moment of this new weight we are looking for. And if you if you check that, so we have the moment of this weight, that will be 35 times the distance from here to here, that will be 35, plus the moment of the weight of the plank, also that will be the weight, which is 45 times the distance is from 50 minus 35, that will give us 50 minus 35 here, equals to the moment of the clockwise moment here, that will give us a weight multiplied by the distance from here B to this point here, that will give us 100 minus 35. And if you simplify that further, that will give us this time, they will give us 1225 plus 50 minus 35 is 15, equals to this. And if you simplify further, we have 1225 plus 675, which is 45 times 15, and equals to 65 multiplied by W, which is representing the weight of the object that is attached to B. Then if you simplify further, that gives us 1900 equals 65 Newton. Sorry, this 65 W65 or 65W, anyone you want to call it. Then divide both sides by 65, so we have 1900 divided by 65. So the weight will be 29.23 Newton for this that will be attached to this point B. Question number 6 is also from the tension, and we are told that an object of mass 7 kg is suspended by 2 light inextensible string, and the SP and YP of length 60 cm and 80 cm respectively. The end of the string S and Y are attached to the same level to 2 points whose distance are apart is 100 cm. Find the tension in the string. Take G to be equal to 10 meters per second squared. So this is tension in an extensible string, and it's still applicable to mechanics as well. You can also study this on physics or further mathematics, anyone. So let's try to draw the diagram. So we are told that there is a 2 inextensible string, and they are both attached. So let's try to the end of the X and Y are attached to the same level to the 2 points. So there's a level where they attach these 2 strings S and Y. So let's call this the level. So if I if I attach X here, so we have X and Y. So S is attached here, Y is attached here. So, and the distance between the two of them is 100 centimeters, you are saying, which is same as 1 meters. And why are we taking to meters? Because the acceleration to gravity is given in meter per second square. So that means all these in centimeters need to be converted to meters as well. So then let's continue the diagram. So this plane is where the 2 inextensible strings are attached. So the first string is SP. So if I attach that one there, so you have this is the first string, and you have a string SP. Then the second one, the length of the string is 60 centimeters. So that will give us 0.6 meters as well. Then also the second string is this, which is Y to P, and that is 80 centimeters to 0.8 meters as well. There's a mass that is suspended by the 2 light inextensible strings. So there's a mass here, so which is attached to this point P here, and that could also be changed to weight. You can find the weight of the mass, which that give us 7 times G, which is going to be 70 Newton for the weight as well. We are coming back there. So also we have to find the tension in the strings. So we need to find the tension in this string, and to find the tension in this string, so we call that one, the first one T1, call the second one T2. So we need an angle in this triangle. Consider a triangle is formed there, so we need an angle here. Let's call that alpha. We need an angle here also. Let's call that one beta, to be able to find resolve the triangle, to find the tension in the 2 strings. The vertical component of the tension must add up to the weight of the object, and that gives us the T1, which is the tension 1 sine alpha, which is this angle, plus T2 sine the angle beta will give us must be equal to the weight of this that is attached to the 2 string. So that gives us equation 1. Also, the horizontal component of the tension must cancel out. So that means T1 cos alpha must be equal to T2 cos alpha. So that means T1 cos alpha will equal to T2 cos alpha as well, which is the horizontal components of the tension. So you can call down equation 2 as well. Using cosine rule, you can see that you can find the value of this angle alpha and beta as well using cosine rule. So using cosine rule, we have 0.8 squared, which is the side facing the angle alpha, equals to the square of the sum of the square remaining 2 sides, which is this and this. So 0.6 squared plus 1 squared will be equal to minus 2 multiplied by 0.6 times 1 cos alpha, if you remember cosine rule very well. So from there you can find the cos alpha from here. So cos alpha will be equals to 0.8 squared, which is 0.64, then minus, if you simplify this, that gives us a 1.36 over, if you 2 multiply what you have in bracket, you have a minus 1.2, and if you divide it properly, we have a 0.6 meter for our cos alpha. If you do the same thing for beta as well, so we'll be having 0.6 square, which is the side facing the cos beta, using cosine rule also. That will be give us 0.8 squared plus 1 squared minus 2 multiplied by 0.8 times 1 cos beta. Then make cos beta also this sort of formula that you have 0.6 square, which is 0.36 minus, if you simplify this, that gives us a 1.6. So take it here, you have a minus 1.6 over whatever you're having here in the brackets. So that will give us a minus 1.6. So equals to, that gives us 0.8 meter as well. So we have the value of the cos alpha and we have the value of cos beta. So we can substitute that into this. Then we can also get for sine alpha and sine beta as well. We can now put that into this as well. We can now solve the two equations simultaneously to find our T2 and T1. So from here, what do we have? From trigonometric identities, we know that a sine alpha is same thing as the square root of 1 minus cos squared alpha. If you remember that a sine squared alpha plus cos squared alpha will give us 1. So from there you can find your sine alpha. But that will give us, by making sine alpha itself formula, we have the square root of 1 minus cos squared alpha equals to 1 square root of 1 minus, we know the value of cos alpha, that is 0.6. There you have 0.6 squared. So from our previous slide, our cos alpha is 0.6, so squared it, then that gives us a 0.8 if you simplify this. Same thing for sine beta as well. So sine beta is also equals to 1 minus cos squared beta. Our value of cos beta, we got that in the previous slide, that is 0.8 squared. So that gives us, if you simplify, that gives us 0.6 meters. So from the equation 1, we have T1 sine alpha plus T2 sine beta equals to W, which is the weight of the mass that is attached. So if you if you substitute our values here, you have 0.8 T1 plus 0.6 T2 equals to 70. And how do we get 70? We are good at giving that the mass of the mass that is attached to the two strings is 7 kilogram. So if you multiply by the acceleration due to gravity, that gives us the weight, that will be 70. So also from the T2, we know that T1 cos alpha equals to T2 cos beta, and we know the value of our cos alpha and cos beta. If you substitute that there, 0.6 T1 equals to 0.8 T2. So if you can make a T1 sort of the formula here, so you can divide both sides by 0.6, so that gives us a 1.33 T2. Then we can now put equation 4 into equation 3 to find our T2. So wherever you see T1, you put 1.33 T2. So your down is coming here. So that means you'll be having this, which is equation 3. Then substitute our T1, then you have 0.8 times 1.33 T2 plus 0.6 T2 equals to 70. Then multiply this out, you have this plus this equals 70. Then add this and this together, so that should give us 1.6664 T2 equals to 70. Divide both sides by this, so you have a T2 to be 42 Newton. So you can now find T1 knowing T2 by putting our T2 here to find our T1. So from equation 4, which is this, so put our T2 here. So that gives us a T1 equals to 1.33 times 42, and that should give us a 56 Newton approximately for the T1. So that ends the question number 5b. So question number 6. Question number 7 is from the combination and permutation. In this case, combination. If 12 combination R is equal to 12 combination R plus 2, find R. So we know that this can be written as 2 factorial. 12 combination R can be written as 12 factorial over 12 minus R factorial equals to this 12 combination R plus 2 can also be written as 12 factorial over 12 minus open bracket R plus 2 factorial R plus 2 factorial as well. So from there, what can we do? it still be like this. Then here we can open the bracket here with this minus here, so you have 12 minus r minus 2 factorial, r plus 2 factorial. Then from there, 12 minus 2 will give us 10 minus 10 r minus r factorial, then into r plus 2 factorial. But so you have 12 factorial here, so this will cancel out this, because even if you cross multiply, this will multiply this will also multiply, so they'll cancel out both ends. So technically this will take care of this. So you have 12 minus r factorial equals to 12 minus 2 give us 10, then minus r factorial into r plus 2 factorial. Then from there, what can we do? We can simplify this to look like this, so that we can 10 minus r factorial can take care of this at this side. So we can expand this 12 minus r factorial. So that should give us a 12 minus r into 11 minus r into 10 minus r factorial equals to 10 minus r factorial r plus 2 factorial. You know how we got this by moving, you start removing remove one from this, you have this, remove one from this, you have this. So that, of course, you know the meaning of factorial by now. So of course this can take care of this at both ends. So we'll be having 10 minus r into 11 minus r, then r factorial equals to r plus 2 factorial. Then from there also we can now simplify this the right hand side as well, so that we can get r factorial as well. So if you expand this as well, so we'll be having this, which is 12 minus r into 11 minus r factorial equals to, if you expand this one, you have r plus 2, r plus 1, then r factorial. By removing one from this, you have this, remove one from this, you have r factorial. So r factorial will take care of r factorial. So you'll be having 12 minus r into 11 minus r equals to r plus 2, r plus 1. Now you can expand the two brackets. Now this multiplied by this, so you have a 132, 12 times minus r give us minus 12r, minus r times 11 give us minus 11r, minus r times minus r will give us r square. Expand this as well, you have this, collect like times, you have 132 minus 12r plus r squared, then r squared plus 3r plus 2. Then take everything. Okay, of course r square will take care of r square, so you'll be having 132 minus 23r equals to 3r plus 2. Collect like terms from there, we have a minus 23r minus 3r equals to 2 minus 32 minus 132 rather. So that will give us a minus 26r equals to minus 130. Divide both sides by minus 26. R will be equals to 5 for question number 7. Question number 8. A pharmaceutical company demands 7,000 units of item for stock manually. The cost per unit order is 550 naira. The cost per unit stock is 200 naira. If the holding cost is 10% of the stock value, find the economic order quantity, total variable cost per annum. Correct your answer to the nearest whole number. So the annual demand is given, which is 7,000 units. Cost per unit, cost per order is which is represented by S. The annual demand is represented by D. That is the cost per order is 550, which is represented by X. Then cost per unit is given also, which is represented by C, and that is the 200. Then holding cost rate, which is represented by H, which is equals to 10% of the stock value, and the 10% of the 10% is 0.1 times the stock value, which is 200. That should be multiplied by this one, and that gives us a 20 naira per unit per annum. Then from there, economic order quantity, which is EOQ, that will give us the square root of 2 ds over H. Our D is the annual demand, and S is the cost per order, and H is the holding cost rate. So if you substitute that into this, you have the square root of 2 times 7,000 times 550 over 2,000. Simplify that, will give us a square root of 385,000, and that should give us 620.48. And that approximately, as well as to approximate it, that gives us 620 units. Then for question Roman figure 2, you have to find total variable cost per annum, which is something as the total ordering cost plus total holding cost, and that should give us a total ordering cost is 70,000 divided by 620, which is the EOQ, multiplied by 550, which is the cost per order, then plus total holding cost, that will be 620 divided by 2 multiplied by 20, which is the holding cost, and that should give us, if you simplify this, that gives us this, simplify that gives us 6,200. Then if you simplify further, that should give us 12,409.14, which is approximately to 12,409 to the nearest whole number. Question number 9 is from binomial expansion. It's from binomial theorem or binomial expansion. You have to write down the expansion. You have to write down the binomial expansion. Write down the binomial expansion of a 1 plus 1 over 2x raised to the power 5 and simplify all the terms. So you have to expand this using binomial expansion, and if you expand it, you have this on the screen right now. And how do we get that? Of course, the first this one will carry power of 5. So, and this will carry power of 0 over 0 factorial. That gives us the first term. So now 5 will come down, so we have 5 times. You remove 1 from the power, that gives us 4. Then this will increase by 1, that gives us 1 over 1 factorial. 4 also will come down, you have 5 times 4. Then remove 1 from the power, you have 3. Then this will increase by 1, you have 2 over 2 factorial. 3 also will come down, you have 5 times 4 times 3. Remove 1 from the power, we have 2. Then add 1 to the power, you have 3 over 3 factorial. 2 will come down, so we have this as well. Remove 1 from power, you have 1. Then this increase by 1, you have 4 over 4 factorial. Then we have the last one also. The 1 will come down also, so we have this raised to power 1 multiplied by 1 raised to power 0. Then this are raised to power 5 over 5 factorial. So we can now simplify this now simplify it to get our expansion. So this will give us 1 over 1. So we have 1 here, 1 plus. So we have 1 over 2 raised to power 1. That gives us 1 over 2. So x. So that multiplied by 5 here. So that should give us 5 over 2 x. Then if you simplify this one also, 1 over 2 squared will give us 1 over 4. Then s squared. Then 4 can take care of 4 here. So that means you have 5s squared. 2 factorial is similar as 2. So that gives us a 5s squared over 2, which is this. Then the next one, you have a 1 over 2 cube. That gives us a 1 over 8. Then 3 factorial is 3 times 2 times 1. That gives us a 6. So from there, so we have 1 over 8. So this multiplied by this, that should give us 20 times 3. That gives us 60. Then 6 can go in 60. That should give us 10. Then we have 10 over 8 s raised to power cube, and that should be 5 over 4. So we have 5 over 4 s cube as well. Then also here you have 4 factorial, which is 24. So 4 factorial will take care of 4 times 3 times 2. So to cancel this, we have 5 left. Then 1 over 2 raised to power 4 gives us 1 over 16. So we have 5 over 16 s raised to power 4, which is this. Then here also 5 factorial will take care of 5 times 4 times 3 times 2 times 1 as well. So we have 1 raised to power 0, that gives us 1. 1 over 2 raised to power 5 gives us 1 over 32. Then s raised to power 5, which is s raised to power 5 over 32. So that means the expansion of this is what you're having here right now. Then question number 9b, you have to use this expansion in A to evaluate 1.00405 correct to 5 significant figure. So the first thing to do is to evaluate this to look like this left hand side that we expanded. So what do? We have 1.0040 raised to power 5. This can be written as a 1 plus 0.040. So you can now change this one to a fraction. That gives us a 40 over 10,000. Then if you simplify this further, you can now compare. If you compare this and this now, so 1 will take care of 1, so we have a half x. So okay, 5 on the power also take care of the power, so you have this is equals to this. So of course 40 can go in 10,000. That give us 250. So that gives us 1 over 250. So this, if you take this one to a fraction, you have a 0.5s. This fraction you have 0.004. Then from there, what can we do? You can divide both sides by 0.5 to get our x. So that should give us 0.008 to be the value of our x. So you can now put that into this expansion to get the value of this. So therefore 1.0040 raised to the power 5 equals to 1 plus 5 over 2 multiplied by s, which is 0.08, plus 5 over 2 times s raised to the power 2, which is 0.0 raised to the power 2, plus 5 over 4 s raised to the power 3, which is this, plus 5 over 16 s raised to the power 4, which is this, then s raised to the power 5, which is this, over 32. So if you simplify for that, you have this as well. Multiply them out and they expand, so you have this because of our time. And if you add this together, you have a 1.020164641281024. We have to take it to 5 significant. So that should give us a 1.020225 significant figure, which is the end of question number 9. So number 9c, you are given that 1 over 16 raised to the power 2s, 16 raised to the power 2 minus 3s is equal to 2 raised to the power 2s. Find the value of this question is from Indices. So we have this. So we can change this one to be 16 raised to the power minus into 2 minus 2 3x equals to 2 raised to the power 2x. Change the 16 to an index form. That should give us a 2 raised to the power 4. So 4 multiplied by this will give us a 2 raised to the power minus 4 into 2 minus 3 equals to 2 raised to the power 2x. Base will take care of the base. So we have a minus 4 into 2 minus 3s equals to 2s. Open the brackets. Minus 8 plus 12x equals to 2s. Collect the like times. 12x minus 2 equals to, so that will give us 10s equals to 8. So s will be 8 over 10. That will give us 0.8 to be value of our x. Question number 11 is from the polynomial. In this case, remainders theorem in polynomial. So we are told that in the polynomial, f of s is equal to 5s cubed plus ps squared minus 9s plus 1 is divided by s minus 3 and s plus 2. The remainder are 163 and minus 17 respectively. We have to find the value of p and q, and we have to find the remainder when p of s is divided by 2s minus 3. So how do we get this? Like I told you, it's from remainders theorem. So when I divide this function by this the x minus 3, it gives us the remainder of 163. When I also divide this function by s plus 2, it gives me the remainder of minus 17 rather, sorry. Then that means you can apply the remainders theorem here. So that is, when I substitute the value of s is equals to 3 here into this function, it should give me the 163, which is the remainders theorem. So if I substitute f of 3 into this function, I should get 163. If I also substitute f of minus 2 into this function, I should also get minus 17. So we have f of s will be 5s cubed plus ps squared minus 9 minus qx plus 1. So if I do f of 3, which is this, into, if f of 3 is equals to 163, so if I put this into this, I should get 163. So that should give us 5 into s cubed, because our s is 3 in here, plus p into s plus p into 3 squared minus 3 cubed plus 1 equals 163. if you simplify further, that should give us 135 plus 9p minus 3q plus 1 equals 163. Collect like terms. So we have 135 plus 1, that gives 136 plus this equals to 163. Collect like term as well. 9p minus 3q equals 163 minus 136. So that should give us equals to 27. Divide through by 3. So if you divide through by 3, you have 3p minus q equals to 9, equation 1. Do the same thing here. So if I substitute f of minus 2 into this function, I should get minus 17 as well. So f of minus 2 equals to minus 17. So if you put that into this function, is to this as well, you have 5 into minus 2 cube plus p into minus 2 square minus q into minus 2 plus 1 equals to minus 17. Simplify further, we have minus 40 plus 4 p plus 2 q plus 1 equals to minus 17. Collect like times. 4p plus 2q minus 40 plus 1 will give us minus 39 equals to this. Collect like times as well. 4p plus 2q give us 22 if this one comes here. So divide through by 2. So we have 2p plus q equals to 11, equation 2. So we can solve equation 2 and 1 simultaneously to find the value of our p and q. So we can see that the coefficient of q here are the same thing, so we can just add these two equations to eliminate q. So add equation 1 and 2, so that give us 2p plus 3p, that give us 5p. Then minus q plus q give us 0. So 11 plus 9 give us 20. So divide both sides by 5, p will be equals to 4. Then substitute, put the value of p equals to 4 into equation 2 to find our q. So we have 2p plus q equals to 11. So our p is 4. If you put that, you have 2 into 4, that gives us 8 plus q equals to 11. So q will be 11 minus q will be equals to 11 minus 8, that gives us 3. So the value of our p is 4, q is 3. So if you substitute that into this function, so we have a complete function there. So we'll be having 5s plus p is 4. You have 4s squared, and our q is 3. So you have minus 3s plus 1. So this is the complete function. Now we are now to find the remainder when f of s is divided by 2s minus 3. So when this function that we have gotten now is not divided by this 2s minus 3, so what is with the remainder? So we can also apply the remainder theorem here. So you can just substitute the value of our f of 3 over 2 into this function to get the remainder. So that will give us when f of s is divided by this, then the remainder is going to be f of 3 over 2. So whatever you get when you put f of 3 over 2 into this, that will give us the remainder. So therefore we'll be having f of 3 over 2 will be equals to 5 into 3 over 2 cube plus 4 into 3 over 2 square minus 3 into 3 over 2 plus 1. Then from there, if you simplify further, so you have 5 times 27 over 8 plus 4 times 9 over 4 minus 3 times 3 over 2. So simplify further, you have 135 over 8 plus 9, then minus 9 over 2 plus 1. Then simplify by finding the LCM, you have this. Then collect, if you add up, you have 179 over 8. So that is that was a solution for question number 11a. For question number 11b, still on sum and product of root of quadratic equation. If alpha and beta are the root of quadratic equation, 5s squared plus 3s minus 2 equals 0, find the equation whose root are 1 over beta squared and 1 over alpha squared. So of course we are given this equation, which is quadratic equation, 5s squared plus 3s minus 2 equals 0. Our a will be 5, our b will be 3, our c is minus 2. So we can get the sum of the root of this quadratic equation. We can also get the product of the root of the quadratic equation. So sum of the root, which is alpha plus beta, will be minus b over a, and that should give us minus 3 over 5, which is the sum of the roots. Then for the product of the root as well, we have alpha beta, that will be c over a, that will be equal to minus 2 over 5. Now that we know this, so we want to get the equation whose roots are this and this. So the equation will become the s squared minus the sum of the roots multiplied by x plus product of the root equals to 0. So these are the equation is going to look like. So we need to find the sum of the roots of this quadratic equation we are looking for, and then we need to find the product of the root of this quadratic equation we are looking for. So, and we are told that the roots are this and this. So if you sum the roots here, so you'll be having s squared minus open bracket. The first root is 1 over beta squared plus second root 1 over alpha squared into x plus the product of the root. So that will be this multiplied by this equals to 0. Then from there you can simplify the bracket here by finding the LCM. So if you find the LCM here, the LCM is alpha square beta square. So beta square in this will give us alpha square times 1 will give us alpha square plus alpha square in this will give us a beta square times 1 will give us beta square as well, multiplied by x plus this times this will give us a 1 over alpha square beta square equals to 0. Then from there we know the expansion of this as well. Alpha square plus beta square is, if you expand this in terms of alpha plus beta and alpha beta, in question number 2, I think we did something like that in question number 2 of this video. So if you expand it, you have this. So alpha square plus beta square give us alpha plus beta square minus 2 alpha beta. Then this alpha square beta square can be written as a alpha beta squared. Then also what you're having here also can be written as this as well. So we can now substitute the value of our alpha plus beta and alpha beta into this now, since everything is in terms of alpha plus beta and alpha beta. So if you simply put that there, you have alpha s squared minus open bracket sum of the root is which is the minus 3 over 5. We have minus 3 over 5 squared minus 2 into alpha beta is minus 2 over 5. Then over alpha beta, which is minus 2 over 5 squared. Then x plus 1 over alpha beta is minus 2 over 5 squared equals to 0. Simplify further. So we have s squared minus open bracket. Square of this will give us 9 over 25. The minus times 1 will give us a plus. 2 times 4 give us 2 times 2 give us 4 over 5 here. Then this will give us a 4 over 25. Then this division can be changed to times. That will give us a 25. If you inverse this, that will give us a 25 over 4 x plus this is minus 2 over 5 that square, that gives us a 4 over 25 as well. So if you inverse it as well, that gives us a 24 over 4 equals to 0. Then you can simplify the bracket here. If you do that, that gives us if you simplify this, find the LCM here, then whatever you now get, you multiply with this one. So you have 124 over 25 x. Then you can take your time to see for multiply how, because this is apply the Bodman's multiplication before we do. So 4 can go in 4, then 5 in 25 give us 5. So that will give us 5 over 1. Then you now find the LCM, that should give us a 134 over 25, I guess. Yes. So from there, plus this equals 0, then you can now multiply through by the LCM of 25 and 4 so that to clear the fraction. So let's say 25 and 4, that will give us 100. So to multiply through by 100, we have 100 s squared minus 536x plus 625 equals to 0, which is the equation whose root are this and this. Question number 12 is from the resultant force. Resultant force. We are told that the resultant of force P and Q has a magnitude of P, while that of 2P and Q also has a magnitude of P. Calculate the magnitude of Q, angle which Q make with P. So, like I told you, it's from the resultant forces, and the first thing to do is to draw the parallelogram to represent put our force P and Q, and the magnitude of the resultant is P. And so draw another parallelogram to represent to put the force 2P and Q, and also the magnitude of the result, which is P as well. So for the first this for P and Q, you have this parallelogram. So first P is here, Q is here as well. So the resultant, which is the diagonal, so that is P as well. You are given the magnitude of that. So for the second, okay, using the cosine rules, so we'll be having P squared equals to P squared plus Q squared minus 2PQ cos theta. So where theta is the angle we are having between the two forces here. Then also we can make use of a formula here, because this will take care of this, P squared will take care of P squared. So we have Q squared minus 2PQ cos theta equals to 0. Then also if you draw the second diagram representing the first 2P and the Q, so you have 2P here, you have the Q here, so the result for is also P, so you have P here as well. So we also have angle theta here as well. So if you use a cosine rule as well, we'll be having this side, which is the result of P squared equals to 2P squared plus Q squared minus 2 into 2PQ cos theta as well. So from there, if you expand this as well, you have P squared minus 4P squared plus Q squared minus 4PQ cos theta. Then from there, if you take this here, so you have a P squared minus 4P squared, that gives us a minus 3P squared equals to Q squared minus 4P squared cos theta equals to equation 2. So this is equation 2 now. So from equation 1, we can make a Q sort of the formula here. So if you factorize Q out here, so you'll be having Q into Q minus 2P cos theta equals to 0. Then if you divide both sides by Q, so Q cancel, divide both sides by Q, you divide this one by Q, you have this left. If you divide this one by Q, you have 0. So from there, you can make use of the formula here. So you have Q is equals to 2P cos theta. So you can call down equation 3. So put equation 3 into equation 2. So equation 2 says that we have minus 3P squared into our Q, which is 2P cos theta. So 2P cos theta squared minus 4P. Then you have Q here. So you have 2P cos theta multiplied by cos theta. So if you expand the bracket here, you have minus 3P squared, then 4P squared cos square theta minus 4P, open the bracket here, you have 8P squared, then cos theta times cos theta will give us a cos square theta as well. Then from there, if you simplify further, we can see that this and this are the 4P squared cos square theta and 8P squared cos square theta can be simplified. So this minus this, that will give us a minus 4P squared cos square theta. So that should give us minus 3P squared equals to minus 4P squared cos square theta. Then from there, what can we do? We can make cos square theta as a formula there. So that will give us P squared. We take care of P squared. You have a minus 3 equals to minus 4 cos square theta. If you make this one for a formula, you'll be having cos square theta equals to 3 over 4. Minus will take care of minus. So you can find the cos theta will now be square root of both sides. That will be square root of 3 over 4 will be 0.8860. So find theta. Theta will be cos inverse of D. That will give us 30 degrees. So then from there, don't forget the question asks us to find the magnitude of Q. Magnitude of Q will be, if you our Q is equals to 2P cos theta here, 2P cos theta from equation 3 here. Q is equal to 2P cos theta. So therefore our Q will now be 2 times our cos 30 degrees, same thing as so 3 over 2. So 2 will take care of 2. So Q will be equals to so 3P. So the magnitude of Q will be so 3P. Then the angle between Q and the angle which Q make with P, which is going to be 30 degrees, which is going to be angle from that is here, which is 30 degrees. So angle Q, Q make angle Q make with P is 30 degrees, which is the angle we are having here, which is the acute angle that is there. Then question number the next question is we have to find the value of, which is from the, what's it called, vector. We have to find the value of x and y if vector A is equal to xi plus j, vector B is equal to 4i plus 4yj, and 3a minus 2b is equal to 1 plus j. So how do we simplify this? We are given that this is equal to this, and we are given the value of the vector A and vector B. So if you substitute that into this, so you have a 3 into vector A is 3i plus j. So you have 3 into 3i plus j minus 2 into vector B is 4i plus yj equals to y plus j. Then you can open a bracket with the 3 and minus 2. You have 3si plus 3j minus 8i minus 2yj equals to I plus j. We can collect like times here by bringing those with high, bring I to high, bring j to j. So we'll be having 3si minus 8i plus 3j minus 2yj equals to this. So you can now factorize I here, factorize j here. So if you factorize that, you have a 3s minus 8i, then plus 3 minus 2yj equals to this. So we can now compare both sides. So this will be equal to this. So high will take care of high. So we'll be having 3s. You'll be having 3s this compared to this. So you'll be having 3s minus 8 to be equal to 1. That will give us equation 1. Then also compare this with j as well. So we'll be having, okay, first okay, before we find x here, sorry, before we do this as well, you can find x here, collect like times. You have 3s equals to 1 plus 8, 3s equals to 9. So s will be equals to 3 by dividing both sides by 3. Then compare this as well. So we'll be having 3 minus 2yj equals to j. So j will take care of both sides. So we have 3 minus 2y equals to 1. So minus 2y equals to 1 minus 3, that gives us a minus 2. So y will be equals to 1 as well. So that ends question number 13. Sorry, question number 12 rather. Question number 13 is from the collision. A truck of mass 20 kg moving at a speed of 8 meters per second collide with another truck of mass 30 kg moving in the same direction at speed of 6 meters per second. After collision, the relative speed of the truck is 2 meters per second. Find the speed of each truck after collision. So this is collision as well. The question is from collision. So we know that principle of collision is momentum before collision should be equal to momentum after collision. So principle of momentum is that momentum before collision should be equal to momentum after collision. And so the momentum before collision is the m1 u1 plus m2 u2 equals to momentum after collision. That's m1 v1 plus m2 v2. And if you find the momentum for the first body, which is for the first truck, that will be mass is 20 multiplied by the initial velocity, which is 8, plus the mass of the second truck is 30 kilograms multiplied by the initial velocity, which is 6. Then after collision, we don't know their final velocity, but we are told that the relative speed of this is 2. We are coming back there. So mass after is still 20 for the m1 multiplied by v1 plus m2, which is 30 multiplied by v2. So from here, if you simplify the left hand side, we have 160 plus 180 equals to 20 vi plus 30 v2. Then from there, that should give us 340 equals to this. You can divide through by 10. So that should give us 2v1 plus 3v2 equals to 4, equation 1. So we are also told that the relative speed of the truck is 2 meters per second. So that means v1 minus v2 equals to 2. That gives us equation 2 as well. So you can now solve these two equations simultaneously to find the speed of the truck after collision. So you can multiply equation 1 by 1, then multiply equation 2 by 3, so as to eliminate v2. So if you do that for this equation 1, we have this. Then for equation 2, if you multiply this one by 3, we have 3v1 minus 3v2, that equals to 6. So we can now eliminate v2 by adding these two equations together. So that will give us a 5v1. 5v1 equals to 40 variable side by 5. v1 will be equals to 8 meters per second squared. Then to find our v2, put that into equation 2. So we have 8 minus v2 equals to 2. So minus v2 equals to 2 minus 8. That gives us v2 will be equals to 6 meters per second. So that's the final velocity of each of the truck after collision. Question number 14. A is from the correlation. In this case, the table shows the values of variables x and y used to conduct a research. We are having values x and y, which is this and this. We have to find the coefficient of correlation between the variable in table 1. So to find coefficient of correlation between these two variables, and so we can use coefficient of correlation. We can use Spearman rank or anyone you want to use. So in this case, we use Spearman rank to find the coefficient of correlation. So of course, we have x, we have y as well. So to use Spearman rank as well, we need to rank the first value of x. We need to rank y as well. So if you rank x from the biggest to the smallest, so this will take rank 1, this will take rank 2, 13 will take rank 3, 11 4, 5, this is 6, and so on. So if you rank y, this will take the first, second, then this and this will take third and fourth. So we need to add third and fourth together. That gives us 7 divided by 2, 3.5, 3.5. Then this will take fifth, this takes 6. So this one will take 7 and 8. Add it together, that gives us 15 divided by 2, 7.5, 7.5. Then you need to find the difference in rank by subtracting this from this. You have 0.5. This minus 0.5. This minus is 0. This minus is 0. 4 minus d, that gives us 0.5. This minus d, you have a 0 minus 0.5. This minus d is 0. 1 minus 1 is 0. Then we need to square the rank, the difference in rank as well. If you square the 0.25, square this as well, 0.25, square this, you have this. So you not to sum together, you have a 1. So the correlation coefficient of using Spearman rank, we have a 1 minus 6 multiplied by the summation of this square over n into n square minus 1. If you substitute the values, we have 1 minus 6 times this square is 1. Summation of this square is 1. You have over our n is, you have 80 data here. So for x and y, we have 8 data. We have 8 into a square minus 1. If you simplify for that, you simplify it, you have a 0.011905. Subtract, we have a 0.9881. So question number 14b is from the statistics. The mean age of K professor in a university is 65 years. 2 professors whose ages are 66 and 68 years left the service, and the mean age reduced by 2 years. How many professors are in the university? Find total age of all professors. Like I told you, is from statistics. So let the sum of their ages be x. So of course we are told that there is mean age, so we need to sum their ages together. So let the sum of their ages be x. Then the mean age will now be sum of their ages, which is x, over the mean age of K professor, so which is number of professors there is k. So the sum of their ages is x, and we have k professors, so the number of professors is k. So, and that will give us the to find mean is the summation of of the data over number of data. So let the sum of the ages of the professor be x, and the number of professors is k. So that gives us the mean. And I'll be giving the mean of the mean of the ages of the professor are 65. So that gives us x over k equals 65. We can cross multiply the s will be equal to 65k. Then from there you can take this one to this side. You have s minus 65k equals to 0. Then you have equation 1. Then two professors whose age are this left the service, and the mean age divided by 2. So it's very simple. So we're having two professors now, their ages are this and this. So if you remove it from the sum here, then that means the total number also will reduce by 2. Then also we are told that their mean age also reduced by 2. So that means you'll be having x minus 66 minus 68, which is by removing their ages from the sum of their ages over the number of professors also will reduce by 2. That will give us k minus 2 equals to the mean age also reduced by 2 years. So that means 65 minus 2 give us 63. Then if you simplify this further, that gives us s minus 134 over k minus 2 equals to 63. From there, collect like times or cross multiply. If you cross multiply, 63 will multiply k minus 2, so that gives us 63k equals minus 126. Take the like term as well. S minus 63k equals to minus 126 plus 134. So that should give us s minus 63k equals to 8, equation 2. So we can solve equation 1 and 2 simultaneously to find the value of our x and k. So, and you can easily eliminate x. So equation 2 minus equation 1. So remove equation 1 from equation 2. So that is remove equation 1 from equation 2. So that should give us equation 2 minus equation 1. Is that what we did here? No. We did equation okay, that's true. Equation, sorry, I'm just equation 2 minus equation 1. That's what we have done as well. So this s minus l give us 0. Then minus 63k minus 65k, that give us a 2k. So then we have 8 minus 0, that give us 8. Divide both sides by 2k will be equal to 4, which is the number of professors that we have in the university. How many professors are in the university, which is number of professors. So we have 4 professors in the university. Then find the total age of all the professors. Total age of all the professors, that will be our x now. So, and then we know that our x here, our s, from which equation, which one are we using? Okay, from equation 1, s is minus 65k equals 0. So if you put our k there, if you take this one here, you have s will be equal to 65k. So s will be equal to 65 times 4. So that will give us 260. So total age of all the professors is 260. So question number 15a is also from statistics. The mean of the number 1, 4, y plus 4, 5, 11, and y plus 1 is y minus 2. Find the value of y, then standard deviation. So like I told you, it's also from statistics, and we are given the mean of all this number to be y minus 2. We have to find the value of y. So we know that the mean is, which is s bar, is, we have to sum this data together divided by number of data. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 data here, and the mean is y minus 2. So if you add those data together, we have this over 7 equals to the mean, and the mean is y minus 2. So if I put y minus 2 here, so we have y minus 2 equals to, if you sum the correlate times here, we have 1 plus 4 is 5, plus 4 9, plus 5 14, plus 11, that will be 25, plus 1 26. So we have 26. Y plus y plus y, that gives us 3y over 7 equals to this. Cross multiply from there. So we have 7 multiply this, you have 7y minus 14 equals 26 plus 3y. Collect like terms from there. We have 7y minus 3y equals to 26 plus 14. So that will give us a 4y equals to 40. Y will be equals to 10 if you divide both sides by 4. So that's the value of y from there. So we have to find the standard deviation. So before we find standard deviation, we need to first of all know the value of our mean. So we need to know our mean first. And how do we know our mean? So we are told that our mean, which is this, we are having a mean which is equals to this. We have our mean is equals to 26 plus 3y over 7, which is what you're having here. Or you can also use y minus 2, which is 10 minus 2, that gives us 8. Or if you simplify like this, you have 26 plus 3 times 10, which is 30 over 7. And that should give us 50 over 7, which is going to give us 8. So the mean of the data is 8, because we need the mean to find the standard deviation. So if you now look for standard deviation of an ungrouped data, that will be square root of the summation of the deviation squared over n, because this is an ungrouped data. Now this is the data. If you arrange it vertically, we have 1, 4, y plus 4, 5, 11, and y plus 6. So if you need to return the value of our y here, which is 10, so as to get the complete value of x. So if you do that, you'll be having our 1, 4, 10, our y is 10, here will be 14, 5, 11, then here will be 11. So we now know the value of our x now. Then the next thing to compute is to complete our deviation, which is x minus s bar. Our s bar is 8, and this is our x. So therefore our s bar will now be 1 minus 8. 1 minus 8, that will give us minus 7. 4 minus 8 is minus 4. 10 minus 8 is 2. 14 minus 8 is 6. 5 minus 8 is minus 3. 11 minus 8 is 3. 11 minus 8 is also 3. Then we need to square the deviation. So square the deviation, we have 49, we have 16, we have 4, we have 36, we have 9, we have 9, we have 9. So we need to sum the deviation together. So if you sum the deviation, we have 132. So if you return that into this formula, you'll be having the square root of 132 over 7. Because our n is 7. We have 7 data here. So that'll give us square root of this, and that'll give us 4.342. So question number 15b, which is the last question for this video, is from game theory. It's from game theory. You are given this game that is played between two competitors, x and y, and these are their strategy. So represented by this 2x2 matrix, we have to find the maximum value of the game, the minimax value of the game, the strategy of the player x, strategies of player y, the value of the game. So the first thing to do is that this is the matrix that represents the game. Now the first thing to find maximum of the game and the minimax of the game. So before we find the minimum of the rows, so maximum means maximum of the minimum, maximum of the minimum. So if we get the minimum, and you can get minimum from the row from the two rows, you get the minimum. So this is the first row, the element there is 2 and 9. So what's the minimum of of these 2 and 9? Between 2 and 9, what's the minimum there? The minimum is 2, and the second row, the minimum here is what? 5. So we have gotten the minimum of the 2 rows. Then for the column as well, you get the maximum. You get the maximum from the column. So you get the maximum from the column. So we have max, that represents maximum. So from these 2 columns, we get the maximum between 2 and 7. Which one is the maximum? That will be 7. And between 9 and 5, which one is the maximum? 9. Are we there? Good. So after getting the minimum here, get the maximum here. So for the first one, we have to get the maximum of the minimum. Now we know the minimum to be 2 and 5. So we are now looking for the maximum of this minimum, and that will be 5. For this one also, we are looking for the minimum of the maximum. We have gotten the maximum here, so we are looking for the minimum, which is 7. So therefore, for Roman figure 1, the maximum, which means maximum of the minimum, and the minimum are 2,5. So what is the maximum of these 2,5? That's 5. Then for Roman figure 2 as well, we are looking for the minimize rather. Minimize means minimum of the maximum. Minimum of the maximum. We have gotten the maximum, which is 7,9. Then which one is the minimum out of the two? That will be 7. So that will be 7. So we have solved question about Roman figure 1 and Roman figure 2. We have done that. Let's go to Roman figure 3. We are looking for strategy of x and strategy of y. Then to do that, we need to first of all get the oddment of this player x and player y. So the oddment for the x, so we need to get that will be the absolute values of the 7 minus 5 for this first row. 7 minus 5, the absolute values of it, 7 minus 5 is S2. Absolute value of 2 is still 2, or the modulus of 7 minus 5, that will give us 2. Then for this second row, that will be 2 minus 9. So we have the absolute value of 2 minus 9, that will give us 7 as well. Then the oddment for this column as well, we need to get that as well. So for this first column, that will be 9 minus 5. So we'll be having 9 minus 5, absolute value of 9 minus 5, that gives us 4. And for this second column, that will be 2 minus 7. So we'll be having absolute value of 2 minus 7, and that gives us 5. So therefore, for the strategy for the strategy for player x, so that will give us 4. That will give us 4. Then out of I'm talking about a player x now, which is this representing this column, the first column here now. So that will give us the 4, which is this oddment, over the addition of the two oddments, which is 4 plus 5. That will give us a 4 over 9. Then for A2, which is talking about this strategy, the second strategy for x as well. Second strategy for x, that will give us 5 out of 4 plus 5, which will give us 5 over 9. Then for strategy for player y, need to get, let's call that one B1. So that will be this 2 over 2 plus 7, that will give us over 9. Then for B2, which is for representing the second row, that will be 7 over 2 plus 7 as well, that will give us 7 over 9. Therefore the strategy for player s will be 4 over 9, 5 over 9. Then strategy for player y will be 2 over 9, 7 over 9. So that's Roman figure 3 and Roman figure 4. Therefore Roman figure 5, which is the value of the game. So the game did not have a saddle point. That could have been the value of the game had it been there's a saddle point, which is the, if this is equals to this, that would have given us the value of the game. But this is not equal to this. That's why we are having a missed strategy. But in this case, to find the value of the game, we'll have depend on what you want to use to be the value of the game. Now I have these two multiplied by these 2 here, plus 7 multiplied by the 7 here, over 2 plus 7. That could be the value of the game. I can also use 9 multiplied by these 2, plus 5 multiplied by these 2, over 2 plus 7 as the value of the game. I can also use 2 multiplied by 4 plus 9 multiplied by 5 over 4 plus 5 as my value of the game. I can also use 7 multiplied by 4 plus 5 multiplied by 5 over 4 plus 5 as value of the game. Regardless of any one I use out of the 4, I will get the same value. So in this case, I use the first one, which is 2 multiplied by this 2, then 7 multiplied by the 7 here, divided by 2 plus 7. That will give us the value of the game, and that will give us 4 plus 49 over 9. That will give us 53 over 9, which same thing as 5 over 5, 8 over 9 as the value of the game. So that is the end of the solution for the Neco 2024 for the mathematics theoretical part of the question. And I want to believe you have learned 1 or 2 things from this video, and I can believe that it's explanatory. And before we close for this video, if you are here to subscribe to this channel, please click the subscribe button on the channel right now. You can also click the notification button so as to notify whenever we post information on this channel. Share this video with students out there who need these resource materials. Like this video, comment in the comment section of this video so as to help us improve in our next video. And as you do so, may the good Lord bless you. Thank you, and God bless you.